The Flashforge Creator 5 Pro offers the perfect conditions for printing challenging technical filaments like nylon or polycarbonate. Its actively heated build chamber, high temperatures, and built-in filtration system, combined with a 4-way tool changer, make it extremely interesting for demanding materials. In this video, I will extensively test if that actually works well in practice for an $849 printer. I'm a professional CNC technician and I have been using 3D printing since it first appeared on the market. Flashforge saw my videos on developing the open source thermoacoustic Stirling engine. Since I need a tool changer with several nozzles for multi-material printing of engine components and support structures, I'm very glad Flashforge provided me with their new Creator 5 Pro. I'm sharing my honest results here, and Flashforge has no influence over this video. Setup and initial startup were very quick and easy. The first multicolor benchy printed with the included PLA immediately showed the best print quality I've ever seen. To be fair, I've never owned a printer in this price range before. Next, I tested printing a 1/4-inch pipe thread cylinder without support structures using PETG. The part turned out great on the first try, without any prior calibration or tweaking. I really wanted to test what the printer can deliver straight out of the box. The dimensional accuracy and print quality are excellent. The thread fits precisely and screws onto a threaded fitting without play and without needing of post-processing. My daughter needs new handlebar grips. I designed the grips in FreeCAD and printed them in TPU. The soft TPU feeds into the extruder smoothly, and apart from a little stringing, which is normal for this material, the print ran completely without issues. I think the result speaks for itself, and my daughter is happy. Next, I tried my first multi-material print. For my high-pressure engine components, TPU is very interesting because its layer adhesion is extremely strong. However, its flexibility isn't suitable for my engine, so stiffening it with PETG would be optimal. I printed 2 nested tubes, PETG on the outside and TPU on the inside. The tool change is very fast and reliable. It completely eliminates the material waste typical of AMS systems, and tool changes barely add to the total print time. Again, there was a typical stringing, but otherwise the print went smoothly and the bond is rock solid. Even with a lot of force, I can't separate the 2 parts. I'm definitely going to produce a few engine components with this material combination and run high pressure tests. My PETG KF40 clamp flange hose connectors aren't strong enough, so now I'm printing them out of PA12CF. The print turns out great. The part looks fantastic and warping was minimal. Especially with nylon, I used to have major warping issues that often forced me to abort prints. The same part printed in PC-PBT-CF yields even better results. And with ASA-CF, the print also turns out very clean and runs completely without trouble. These filaments are high strength and can handle the demanding requirements inside the engine. PC-PBT-CF in particular is incredibly tough. In terms of stiffness, you could almost compare it to aluminium. Thanks to the high bed temperature of 120 degrees Celsius, the actively heated build chamber at 65 degrees, and up to 320 degrees at the nozzle, the warping problems seems to be solved. After sealing, the parts are permanently high strength and pressure tight. Removing support structures with these materials is a real pain, so I'm looking forward to multi-material tests using easy-to-remove support filaments. So far, I'm more than satisfied with the Flashforge Creator 5 Pro. It delivers excellent results out of the box with all the materials I tested, even the challenging ones. So I'm going to start designing and printing a lot of engine components now. I will report on that in the next video. As always, I really look forward to your feedback, suggestions and thoughts in the comments, on Discord or at ownenergy.org. You will find the links in the video description. Thank you very much for watching.